In Lesson 4.5, Scatter Plots and Lines of Fit, you will identify relationships between quantities by using a scatter plot and also use lines of fit to make and evaluate predictions. Scatter plots are used to investigate relationships between two quantities. Those two quantities are shown as ordered pairs that can be then put on a coordinate plane. And when you plot all of those ordered pairs, if they tend to go somewhat in a line going upwards, it's said to have a positive correlation, the two quantities. If they tend to go downward in a line, it's said to have a negative correlation. And if they're just kind of scattered all over with no real rhyme or reason to it, it would be said to have no correlation between those two quantities. Our first example says, determine whether the graph shows a positive, negative, or no correlation. If there is a positive or negative correlation, describe its meaning in the situation. Well, these points tend to go in a line going upwards, so that would be a positive correlation. And what that means is that as the number of hours increase, the wages increase. Scatter plots can show whether there's a trend in a set of data. When the data points all lie close to a line of fit or trend line can model the trend. In example 2, you're going to write a line of fit. It says the table shows the largest vertical drops of 9 roller coasters in the United States and the number of years after 1988 that they were opened. Identify the independent and dependent variables. Is there a relationship in the data? If so, predict the vertical drop in the roller coasters built 25 years after 1988. Well, if here's our information, 1 year since 1988, the vertical drop was 151. 3 years since 1988, the vertical drop was 155. Each one of these is going to be a data point on your graph. The years since 1988, that's going to be your independent variable, or the years since 1988. And then the dependent variable is going to be the vertical drop. So if we want to make a scatter plot, we're going to put the years since 1988 on the bottom, vertical drop going along the side. You want to make sure you have equal intervals on your x and y axis. And then each one of these data points here is going to be a point on the graph. So 1 year since 1988, it was 151. 3 years since 1988, it's going to be 155. 5 years since 1988, it's going to be 225. And then 8 years since 8 years since 1988 is going to be 230. So you'd continue on and graph plot each one of these points on the graph. And then you will draw in the line of fit. Basically, you're going to look at your points and you're going to draw a line that kind of goes through the center of them. It says no one line will pass through all of the data points. Draw a line that passes close to the points. A line of fit is shown right here. Write the slope-intercept form of an equation for the line of fit. The line of fit passes close to 2,150, so it's really close to 2,150, which is right there. And it also goes through the data point of 12,300. Goes through that point right there. So we're going to use those 2 points to write an equation of the line of fit. So if these are our 2 points, 2,150 and then 12,300. The first thing we're going to do is find the slope. Remember, the slope is the change in y over the change in x. So we're going to go like this and do 300 minus 150. Over 12 minus 2. So the slope's going to end up equaling 150 over over 10. 150 divided by 10. When you divide by 10, you just move the decimal one place to the left. So that's going to equal 15. So m is equal to 15. Now that we know what m is equal to, we can take one of the points. I'm going to use this one right here. Use one point and the slope, and then either the point slope formula or slope intercept formula to figure out the equation of the line. I'm going to use the slope intercept formula because that's what most people in class said they like to use. So y equals mx plus b. So in place of y, I'm going to put 150. In place of m, I'm going to put the 15 that we found for the slope. In place of x, I'm going to put 2, and we don't know what b is. So now we have 150 equals 30 plus b. So 100, or we're going to subtract 30 from both sides. So we have 120 equals b. So now that we know that m is 15 and b is 150, we can go ahead and write our equation. Y equals m, which is 15, x plus b, which is 120. So there's our equation for the line of fit. Now if we go back up here to the question, it says, predict the vertical drop in a roller coaster built 25 years after 1988. Well, 25 years after 1988 means we're going to plug in 25 for x. So we're going to say y, or the vertical drop, equals 15 times 25 plus 120. So 15 times 25 is 375 plus 120. That equals 495 feet. We predict that 25 years after 1988, the vertical drop would be 495 feet. This line of fit would help you to predict some data that's beyond our graph as well. Like we could put in 20 years, which isn't going to show on our graph here, and we can predict in 20 years since 1988 how much the vertical drop would be. Or in this case, we did 25 years, which was beyond our graph as well.